Welcome to Building Secure by Design Environments with Azure Capabilities. My name is Gideon Ordo, and I'm one of the founders of a cloud security startup called 𝗦𝗽𝗲𝗸. Prior to starting the company, I was working for AWS, leading a product called AWS Security Hub, which is the native CSPM for AWS. During that time, talking to hundreds of customers, they've repeatedly told us that all things being equal, they would like to use the native built-in security capabilities into the cloud providers, but that they struggle doing so because they're like technical building blocks that they need to go and build on top of and integrate in order to get to a full security solution. We therefore started 𝗦𝗽𝗲 with the vision of being a unified operating system for native built-in cloud security capabilities, allowing customers to use them to get to secure by design cloud environments. In today's session, we will start talking about why security by design is important, but also why it is complex to achieve. And we will do that through an example. I will then discuss Azure policies as a core capability that Azure offers to allow you to get to a secure by design environment. I will then discuss how to define a cloud security standard, which are really the set of requirements for a secure by design environment. And finally, I will discuss how 𝗦𝗽𝗲 allows you to do that very simply. So let's start with our example. Everything should be encrypted at rest. The traditional detective approach has you go in, install a CSPM that will give you a list of oftentimes thousands of non-encrypted storage accounts, for example. After you have the list, the security administrator would go one by one, find the owner of that, and either work with them to remediate to make sure that it's encrypted, or to list an exception as to why this use case requires something that's not encrypted. After going through all of those, which can take months, so sure, you finish going through all of them, but because people continue working with the cloud, there could be a list of hundreds of more instances that then has to be remediated. So this leads to a sort of an everlasting cycle that never ends of remediation and fixes, but also new ones being created. With the secure by design approach, we complement the detection that I mentioned before with preventive policies to make sure that no new storage accounts can be created. And after doing that for storage accounts, both the prevention and the detection and remediation, you can do the same for all of the other resource types within Azure and within your other cloud environments that can be encrypted. The secure by design approach is something that the industry is moving towards. And even within Microsoft, their executive vice president of security, Charlie Bell, has said about a year ago that they have evolved their security approach with the work being guided by the primary principle of security by design. And they work on that both internally for the Azure environment, but also on the capabilities that they provide customers. And really the core such capability is Azure policy that allows you to achieve secure by design. It allows for policy enforcement at the provider level. So no matter how you do things through an API or through the console or through the command line or through a pipeline, policies will be enforced. It offers a combination of deny policies and audit policies to allow you to both prevent as well as detect and remediate. Azure policies scales together with your environment, which means that as you create new subscriptions or workflows, you don't have to do anything. The policy scales together with you. They support most, if not all, of the Azure API attributes to provide really wide enforcement with hundreds of built-in policies and custom ones that you can create. And to bridge the gap between the audit policies that we mentioned and the deny policies that I mentioned, there are also remediation tasks that really automate the remediation of non-compliant things flagged by the audit policies. To use Azure policies to get to everything being encrypted, you need to use a combination of both built-in and custom deny policies, as well as a few audit policies and remediation tasks to help you clear up all existing resources. We start with storage accounts like we started in the previous example, and we use for that both deny policy as well as an audit policy with the remediation task to clean up all existing resources. And then we go over other resources and add additional policies. What you can see to the side is a custom policy to prevent the creation of all non-encrypted SQL databases. So really the same thing we did for storage accounts, but here for SQL databases, and it uses a custom policy because Azure doesn't offer a built-in policy for that one. But security by design goes really beyond that. It allows you to manage your cloud footprint, what regions you can use or what services you can use. It allows you to place data protection mechanisms to say, for example, who can access sensitive data. And it allows you to manage privilege actions and put in either identity controls. And these are all just examples. And as you go in and define what the security by design for your environment looks like, what you actually create is sort of a cloud security standard, a collection of requirements and guardrails that are used within your environment. To define that standard, you as the security administrator first need to go in and collect all of the security requirements. You need to make sure that they are clear so that you can implement them, but you also need to communicate those requirements with the organization so that they know how to use the cloud. On the bottom half of the slide, you can see several requirements that should or should not be a part of a cloud security standard. The first two requirements here are very succinct, very clear, and should definitely be a part of such a standard. The second two requirements should not be a part of a standard, but rather should be further refined. This is because the first one that says, unless in emergencies, is not clear enough. What's an emergency? When is that happening? And the second one is really long, how to process, how to understand, and needs further refinement and clarity before it can be translated into technical controls. So really, let's do that. We take that paragraph and we can translate that into three separate requirements. The first being only access external resources if they belong to an approved partner. The second being only perform write actions into encrypted data stores. And the third being only allow outbound internet connectivity to approved networks. And while these requirements are now very, very clear, it can still be hard to translate each of them into Azure policies. Each of those requirements can translate into dozens of policies, dozens of custom policies that you need to go in, write, resulting in very long technical documents that are hard to define. Even after writing the policy, you get to the rollout phase, and rollout can be extremely slow because you need to go, simulate the policy, understand its impact on your environment, and manage exceptions along the way. And as you do that and try to understand existing usage, and you might need to manage exceptions, those become how to manage, and you have to manually embed them into the policy that you previously wrote. Even after installing a policy and rolling it out, you need to manually maintain it as your use of your cloud evolves or as the provider launches new capabilities, making this a lifelong project instead of just a point-in-time policy installation. This is really where native comes in. So let's take one of those security intents. Sensitive systems can only be accessed from approved locations. When you put that into native, native not only translates that into the technical enforcement capabilities, but it also takes those and simulates them to understand their impact on the environment, and then using the result of the simulation, as well as other information that's collected on your cloud environment, native tailors the policy to make sure that there is no adverse impact. This results in a rollout of up to 74 policy documents in Azure for this one specific requirement. And similarly, in other providers, it can result in many policies as well. So in AWS, for example, this would use 4 different policy engines with more than 30 different policies being rolled out. Perhaps to take a bird's eye view and step out of that example, this is where native allows you to easily and quickly ensure security by design. We use the native built-in security capabilities to provide security at the source, security within the provider itself. Beyond that, we offer a unified governance engine from which you can go in, reason about your security objectives, and we translate them to security capabilities across cloud providers. Each of those capabilities can be operationalized end-to-end through native, with simulation of new policies, understanding impact of existing capabilities, and always monitoring for drift. And finally, native provides adaptive coverage to your security capabilities as your cloud evolves and as cloud providers launch new capabilities, to always make sure that you're up to date and that your security standards match how you use the cloud. So thank you again for joining us for this session, Building Secure by Design Environments with Azure Capabilities. We discussed not only why security by design is important and how to do that within Azure, but also how native can help you do that much faster and much more easily. To learn more, please visit our website at native.security, where you can learn more, see a demo. We look forward to chatting. Thank you very much.